all the students. Today we are going to study switching techniques. So basically when we are having a large network, we know that in a large network there can be multiple paths from sending the data from the source to the destination. So one source and one destination can have multiple paths for the transmission of data, right? So basically switching techniques helps us in deciding the best route for data transmission out of the available paths. So like if there is a source and destination, and for transmitting the data from that source to that particular destination, assume that there are 4 paths. Now out of 4 such paths, deciding on which is the best path is done by the switching technique. So like best path is usually calculated on the basis of the distance which is traveled, or the path which is having less congestion. Like when I say distance travel, that means the path which takes the less amount of time for transmitting the data from sender to receiver, or the path which has minimum congestion or minimum number of packets. So depending upon these particular criterias, you choose the best path, and the task of choosing this best path on the basis of certain algorithms is done by the switching technique. So that is why switching is an important thing in networking. Now, basically the switching technique helps to connect a one-to-one communication between the sender and the receiver. It is a one-on-one communication directly between, that is from the sender to the receiver. If I talk of the switching techniques, there are 3 kinds of switching techniques, or 3 types of switching techniques. First one is the circuit switching, then is the message switching, then you have packet switching. So today we are just going to focus on circuit switching. Message switching and packet switching we'll cover in the next videos. So as of now, in this video we will focus on circuit switching. Now talking of circuit switching, it can further be divided into 2 types of switching. One is your space division switches and other is your time division switches. So basically circuit switching is one of a kind of a switching technique, and it can further be divided into 2 types of 2 subcategories, which is your space division switching and your time division switching. Now one term that we'll come across many times in while studying switches is cross points. So let's clear this concept of cross points here itself. So what are cross points? Basically they are collection of switches, right? Various switches, group or collection of switches which are arranged in the form of a matrix configuration. So the topology or the configuration is such that they appear to be in a matrix form. So all such switches are arranged in a matrix configuration, and of course it consists of multiple input and output lines, as in the case of any switches. So there are multiple input lines from which the data is coming, and there are multiple output lines from where the data is going for the destination. So these inputs and output lines form crossed pattern of interconnecting lines. There are interconnecting lines because of the input and output lines which are coming and going, and because of this there is a crossed pattern which is formed. So this particular crossed pattern of input and output lines which form interconnecting lines is basically known as your cross points. Okay, so as I said, we'll focus today on circuit switching. So what is circuit switching? Circuit switching is basically a switching technique that establishes a dedicated path between sender and receiver. Now when I say dedicated path, that means a path that is completely reserved for that particular sender and receiver only, and no other sender or receiver other than these 2 parties or these 2 nodes can transmit data through that path, right? So just like in a telephone connection you have a dedicated path, similarly in circuit switching also there is a dedicated path. That means a path that is exclusively reserved for that particular sender and receiver, and no other sender or receiver other than this particular sender and receiver can transmit data through that path, hence dedicated path. Now once the connection is established, right, the first and foremost thing here is first of all connection establishment. Once the connection is established, only then you can transmit the data. So once the connection has been established, the dedicated path will remain to exist until the connection is terminated, right? So until the connection is terminated, this dedicated path will remain there for this particular sender and receiver. So when any user wants to send data, it can be any kind of data, it can be textual data, it can be voice data, it can be video. So what that user does, basically the sender, it sends a request signal to the receiver, right? So receiver receives a request signal from the sender, which means that the sender is interested in sending some data. Now, if there is availability of path, such path which can be exclusively reserved for this particular sender and receiver. So if there is such dedicated path is available, such exclusive path is available, then the receiver will send back an acknowledgement to the sender. So if there is no such path available, then the receiver will not send an acknowledgement. So if such path is available, only then the receiver will send an acknowledgement. So an acknowledgement to the sender itself means that there is availability of an exclusive or dedicated path. So once the sender receives the acknowledgement, that means a connection has been established, and then the sender can transmit the data to the receiver. So there can be transfer of data between the sender and the receiver. Circuit switching is basically used in public telephone networks. As I said, just like in telephone networks, you have a dedicated path. So circuit switching is basically used in public telephone networks. It is usually used for voice transmission. So there are three phases in circuit switching communication. That means there are three steps for performing circuit switching communication. So first is of course your circuit establishment. So the circuit or dedicated path is established when the sender sends a request to the receiver, and if there is an exclusive or dedicated path available, the receiver sends back an acknowledgement to the sender, and then the circuit or path is established. Then second, once the path has been established, obviously the second step would be to begin with data transfer. So once the circuit or path has been established, data transfer can begin. Once the entire data has been transmitted and the sender does not need the field to transmit any data further, the circuit is disconnected or the path is disconnected. So basically, if I consider A to be the sender and B to be the receiver, so there are various switches. This S1, S2, S3, S4, S5, S6 represent the switches. So there are various paths which are going from S1 to S6. There are multiple paths, as you can see here. So in circuit switching, a dedicated line or dedicated path is there for sender A and receiver B, and sender A is then transmitting messages one by one, like message 1 went first, then went message 2, and then message 3. So this is a dedicated path or dedicated transmission line that has been chosen for the for the data transfer between A and B by the switches. So circuit switching can basically, now further if I subcategorize circuit switching, it can be subcategorized into two technologies. One is your space division switching and another is your time division switching. So first we'll talk about space division switches. It is basically a circuit switching technique in which a single transmission path is accomplished in a switch by using a physically separate set of cross points. So basically a single transmission line is chosen and which is physically separate from all other lines, and it consists of a separate set of cross points. Space division switching basically can be achieved by using crossbar switch, a technology known as crossbar switch. Using this technology, space division switching can be achieved, right? What is a crossbar switch? A crossbar switch is basically a metallic cross point. It also consists of cross points, but these cross points are metallic cross points which can be enabled or disabled by a control unit. So you can basically enable or disable these cross points with the help of a control unit. Now the crossbar switch is made by using a semiconductor material, And space division switching has high speed and high capacity. This is the advantage of space division switching, which uses crossbar technology or crossbar switches, that it has a very high speed and a high capacity. Now, as I said, it uses crossbar switches, but it also sometimes uses multi-stage switches. So basically, I can say that these space division switches can further be categorized into two types. One is your crossbar switch, which we just discussed, and then is your multi-stage switch. So as I said, crossbar switch basically consists of semiconductor material, and they have metallic cross points. So they can be enabled and disabled using a control unit. So basically in a crossbar switch, it has n input lines and n output lines. That means same number of input lines and the same number of output lines. And if I talk of the intersection points or the cross points, it has n to the power 2 or n square intersection points, which are your cross points. Then if I talk of the disadvantage, as we know that everything has its pros and cons. So if I talk of the cons or disadvantages of a crossbar switch, it is that as the number of cross points increases, the number of cross points increases as the number of station increases. That means more stations, more cross points, which will make it complex, or which will increase its complexity, right? So the solution to this is to use multi-stage switches. Now, what are multi-stage switches? Basically, multi-stage switch is made up by splitting the crossbar switch. The same crossbar switch which we just talked about, or which we just talked of, is split into smaller units, right? And then these smaller units are interconnected. So basically, what it does, it reduces the number of cross points first of all. And then the other advantage is that if out of all the paths available, if one path fails, then there is always an availability of another point, another path, because you have split the crossbar into smaller units. So there are more paths available. So even if one path fails, in that case, always there is another path which is available for data transmission, right? So we have talked about space division switching or space division switches. Now another subcategory of circuit switches is your time division switches. So what are time division switches? Basically, in time division switches, the incoming and outgoing signals are received and transmitted in a different time slot. So we can say that time division switches uses the concept of, or work on the concept of, time division multiplexing. So the incoming signals and the outgoing signals are received and transmitted at different time slots and not at the same time. So basically the main difference between space division switches and time division switches is that sharing of cross points, right? That means in a space division switching, the cross points are shared by both input and output signals. But in case of time division switching, they are allotted different time slots. That means the input signals will use these cross points at a different time slot, and the output signals will use these cross points at a different time slot. So this is the main difference between your space division switching and your time division switching. So basically cross points are not shared in space division switching because because the input signals and output signals are using the cross points at the same time. Hence, we cannot share the cross points in space division switching. Hence, cross points are not shared in space division switching, whereas they can be shared in time division switching because we are using the same cross points at different time slots. So basically input signals will be using the same cross points but at a different time slot, and the output signals will be using the same cross points again but at a different time slot. So basically in case of space division switching, cross points are not shared, and in case of time division switching, cross points are shared but for shorter periods. I mean these switching between these time slots is very quick, hence for a shorter period. Now, what advantage do we get out of this, out of the time division switching? It helps in reassigning the cross points, right? You can reassign the cross points once to the input signals and then to the output signals, right? And all the associated circuitry of the cross points for other connections as well, right? So basically, time division switches use, as I said, the concept of time division multiplexing in switching. Okay. Now we have discussed a lot in detail about circuit switching. Now let us look at the advantages and disadvantages of circuit switching. So first of all, we'll discuss the advantages of circuit switching. Basically, the communication channel is dedicated, right? The first advantage is that you have a dedicated channel for transmission in case of circuit switching. Then it has a fixed bandwidth, so you do not have to worry about the bandwidth also. So these are the advantages. Then if I talk of the disadvantages of circuit switching, the disadvantage is that once a dedicated path has been established, then delay occurs in the speed of data transmission, right? There is a delay in the speed of data transmission. Usually it takes a long time to establish a connection. Before actually transmitting the data, as I said, you have to first of all establish a dedicated path or connection. So the establishment of this particular connection takes a long time, which is approximately 10 seconds, during which, of course, during which you cannot transmit any data. During connection establishment, no data can be transmitted. So approximately 10 seconds are wasted. Then, of course, it is more expensive. Why? Because you have to establish a dedicated path, right? So that is at a cost. So hence it is more expensive than other switching techniques. So this was all about circuit switching. If I talk about some disadvantages, then it is inefficient to use, because once a path has been established, right, and if there is no data to be transmitted during that particular time, then the capacity of the path is wasted, because you have established a dedicated connection, and then if there is no data to be transmitted, of course the capacity of the path or the bandwidth is wasted, right? Now, since the connection is dedicated, therefore only that particular sender and receiver can transmit their data. Whether or not they have something to transmit, the path will remain exclusively for those sender and receiver, right? So even if the channel is free, no other sender or receiver can exchange data during that particular time. So these are the disadvantages of circuit switching. So this was all about circuit switching.